get back to our scheduled talks. So now at 2, we have Daniel Gruffat from Nanome. Is that pronounced for? And Daniel's a computational structural biologist working on structure-based drug design in virtual reality, and has a very nice talk on this plan. So thanks and welcome, and we look forward to hearing you. Thanks.
Sure. Glad to be here. Thanks for having me, and thanks to everyone watching the presentation. So, yeah, I guess, can you see that in full screen?
Yep. Yeah, we can see it.
Great. So let me go to the first one. Sorry about that. Okay. So thanks, everyone. Yeah, my name is Daniel, and like Finif said, I am a computational structural biologist. I've been using, modeling and visualization softwares for a long time. And, the moment I tried Nanome for the first time, it really blew my mind. It's an incredible software. I'm going to be showing it to you guys. Hopefully you'll agree with me. And yeah, let's go for it. So we like to call it the next step for structure-based design. It's a very intuitive platform, as you can see, in which you can actually interact and embrace your molecules and just interact with them with your own hands in an immersive environment. So yeah, let's take a look at it. So, spatial computing, this AR and VR, virtual reality, it's really the next major computing interface. It allows for a much more intuitive interaction with your data, definitely more than the keyboard and mouse or even the touch screen from our cell phones. So traditional two-dimensional methods, as you can see here, even though they show interactions between the ligand and the protein, they always have a risk of information loss. Right? It's just hard to visualize, analyze, and also communicate structural data on a flat screen. It's just not the best way to do so, right? So in this case, we see this is a RIP2 kinase, by the way, and even in the figure to the right, which shows the surface, there's some nuances there from the pocket that it's just hard to tell. It's not that great. So there's been past attempts at three-dimensional visualizations, such as this star cave at the University of California. So, what we've been hearing from the community is basically that it lacked the ability to interact or modify with any of those structures. It's not an intuitive platform. It's also a large deployment, expensive, and actually NVIDIA has stopped support for these types of systems. So, as I'm sure you know, structural data is on the rise. More and more structures are being deposited every year in these public databases, and it's playing a major role in drug discovery to accelerate the process, really. So virtual reality allows for a much deeper understanding of any structural features of any targets or any molecules you might be working on. Here, in this case, this is actually a mixed reality footage where you can see an actual person there interacting with the two avatars that are joining in virtual reality, and they're just analyzing this binding pocket in 3 dimensions, and therefore gaining a much better understanding. So you can grab a molecule and scale it really big and get inside the molecule, really inside a binding pocket or any other area of interest. You can import any structures from RCSB, PDB, PubChem, Drug Bank, and others, and and even from your own computer, locally from your proprietary database. That's also possible. And what's also really great is that if you have any sessions or files from other software, such as MOE, Maestro, and Pymol, those files and sessions are also supported. So if you load those within our platform, it will maintain the original representation. So you'll see everything just as it is. And then you can make further modifications as well to that workspace and further save it. So that's been shown really helpful for teams working in drug design. So it's a very intuitive, as I mentioned here, you can just interact with your own hands. that really allows for a level of interaction and intuition that was not possible ever before than with the virtual reality. So you can see here how to the left, you can see how with their own hand, the avatar is rotating a side chain of a residue. And to the right, well, they have a tool actually on their hand, which can be used to make measurements between two atoms, or perhaps measure an angle or a dihedral angle, and more. Even there's a medicinal chemistry tool for building, making edits on the fly, deletions, further minimizations, and all these things. So really intuitive and really helpful because of you interact with your own hands with any molecules of interest. Here, it's actually a drug design session where two avatars, two people, they're located in different locations, by the way. They're just building some functional groups in there as they hang in their binding pocket themselves. So they have a library of atoms and groups that they may want to add or perhaps delete. They are further minimizing the structure right afterwards. And then they can also visualize any clashes, calculate any hydrogen bonds and other chemical interactions as well. So what's also really impactful about this platform is that it integrates with any computational chemistry packages that you may have already, that you may be using on your daily or weekly workflows. So Nanome has a Python-based API that connects with any of such packages and databases. So in this case, this is one example of one plugin of it's RDKit, which it's used for calculating chemical properties. So you can see how the avatar is building some atoms in there with his own hands to the molecule, and then in the background, it's updating in real time in 2 dimensions. So you can take snapshots and then compare it against another snapshots, and the properties also get updated in real time, such as the molecular weight, log p, and all those, and then you can further export all that data in a spreadsheet as well. So yeah, this is one example, as I mentioned, for chemical properties, but there's other examples such as molecular docking, which right now it's working with Smina, Autodoc Smina, which is a fork of the popular Autodoc Vina. So it's very easy to use. You can select the number of binding poses that you might want to obtain from the software. You could actually rank those poses based on the score that you get from each of those. And then, you can just cycle through them individually or in a loop. You can further modify any rendering or anything within the molecule as you see your binding poses. So this has been really great to do some dockings in virtual reality. And for computational chemists, it's really great to also play trajectories of molecular dynamics simulations. You could play such trajectories within Nanome. And as you can see here, the measurement that you can make between two atoms, it actually updates in real time as you play the trajectory. So that's something that can be useful, for example, for understanding cryptic pockets and in other use cases as well. So, by the way, for crystallographers, structural biologists, this electron density maps is been really helpful as well. You can superimpose multiple maps actually, and then modify any of those radius, the opacity, the sigma values, and then it supports the most common file formats for these maps, such as CCP4 and DSN6. And we have also a functionality which you can load, by the way, PDFs and PowerPoints to the platform. So also we have a whiteboard that you can pull, and just with a pen, a virtual pen, of course, you can sketch and draw just as you would be doing, in a real drug design session. We want to replicate what happens in a real drug design session. So that's doable within the platform as well. Just draw, highlight anything, sketch, brainstorm on a whiteboard, all these things. So it's really helpful for teams to collaborate. So workspaces can be customized, can be exported to any of those common files such as PDF, STF, even smile strings. And one great thing that I'm happy to announce now is that we have a very new feature, which is called the Spatial Recording, which you can record and play back in VR. And also it's possible to make two-dimensional videos as well. So the good thing is that you can do asynchronous communication, knowledge of transfer, or even prepare tutorials or prepare presentations. And so, like I said, you can play back those presentations in virtual reality. So that's great for collaborating with teams. And by the way, talking about collaboration, this is actually one of the biggest features of Nanome, besides the fact that it's a three-dimensional platform. So what happens is that people can join the same virtual room regardless of their geographical location. So in this case, we have a test here that we did with people really all over the world, from Australia to Japan, Europe, and the United States. So, it really the experience is really smooth with no lag, and the reason for that is that there's really no video being transferred via the network. It's actually mostly coordinate data, and therefore it allows for a very smooth experience. So it's been shown very helpful for drug design teams to collaborate in real time, even if someone might be at home, then the colleague might be at the office, but then another colleague might be at a different city or a different country. And so this really helps accelerating the drug design decision making. It's really like a virtual co-working space. So I wanted to show today some work we've been doing on KRAS for oncology research. So we have here, this is a work by Bayer that helped identify novel covalent allosteric binders for KRAS. So we see here, I'm pointing at the cysteine-12. Of course, that's bound to that inhibitor, and then we overlaid another inhibitor in orange, just because we wanted to compare a little bit between the two. And so, we were, the team discussing and having a collaborative session. The four of us were in different cities, and it's just great to collaborate this way. Absolutely, you can point at any part with your own hands. You can modify anything on the fly. You can just accelerate any decision making, communicate structural data real quick. It's really awesome. And this is part of the same session, just showing the surface of the KRAS and grabbing the molecule, scaling it, and taking a look at the exterior of the binding pocket. We have the GDP on one side and the inhibitor on the other side. Okay, so how has Nanome helped other organizations? Well, we've been working with Novartis since 2017. We've actually put out a paper together, which is this one over here, in the Journal of Molecular Graphics and Modeling, which basically describes the development of the platform. So we started with them in San Diego, and now we've been helping them connecting their teams across San Diego, Boston, and Northern California. And we co-authored this paper, and we are really happy to be working with them, and apparently they are as well, since they've been not only renewing, but actually expanding over the years. And lately, by the way, they've been using Nanome to help develop some drugs for coronavirus. So that's been great to collaborate with them with regards to that. So another use case. Another case study we have is with the Life Arc organization in the UK. And they've been leveraging our software to build their own Python plugins to further enhance their existing workflows. So that's been great, really, to collaborate with them and see how they just so eager to develop their own plugins and connect with their own packages and just do whatever they want to do, but in virtual reality, connecting with our platform. Lastly, I wanted to mention this case study we just recently have with Nimbus Therapeutics in Boston. So, in collaboration with the Oculus, which is one of the makers of hardware for virtual reality. So this case study is amazing because they describe how they've been able to save tens of thousands of dollars and per year. And the reason for that is basically because they've been able to send out to synthesize not just a good molecule that would potentially be not so great down the road and then potentially be a waste of time and waste of resource or waste of money. But actually they've been able to build and send out to synthesize the best molecule they possibly could. And that was possible because of working with this virtual reality environment where they can really get all the nuances of the three-dimensionality. That's how impactful really this platform is. So to summarize, Nanome is an effective drug design decision-making platform to enhance creativity and intuition, and for global collaboration is definitely amazing, as we've just discussed, and then for integrating with any platforms. So collaboration, integration, and intuition, definitely that's Nanome's core. So thanks very much, everyone. I'm happy to take any questions that you might have, and welcome to Nanome.
Yeah, thanks so much, Daniel. Yeah, so if you have any questions, we can almost wait for them to come in. All right. Well, thanks so much. Really appreciate your great talk. I don't know if we have a couple minutes before the next talks, Sam, or do you want to transfer everyone over?
Yeah, thank you again, Daniel, for your great presentation. We are a little earlier. Our next presenter is at 2:30, so we'll take a little quick break right now. If the audience haven't had a chance to grab a afternoon tea or a coffee, this is the right time to do so. And if you are looking to connect with Daniel and his team, you can send a meeting request to them directly, and we can connect you with him for a small intro to his platform. So we'll take a quick break, guys, and we'll be back for 2:30 session with Dr. Andrea.